Hi and welcome again, everyone. In this video, I want to go over planes in R3 and how we can find the equations of planes. There are two approaches to that, and I'll try to cover both of them. So before I start this video, it's a very good idea to watch my videos on dot product and cross product, because if you watch those first, then this section is going to be very easy for you to understand. However, I did review those fast in this lecture, but please go ahead and watch the dot product and the cross product first. And when you come back and watch this one, you'll see it will be very easy. Or just finish watching this one and then go directly to dot product and cross product. Okay, let's start. Now, again, in R3, if we have a plane, and I try to draw that for you, there are some little details to notice, and then I'll show you how we can find the equation of a plane. First of all, we're going to go here. We have this point, which is P0. The coordinates of that point are x0, y0, z0 is in the plane. Now, each plane has a normal vector, and the normal vector is orthogonal. Orthogonal, we know by now it's perpendicular. It is perpendicular to the plane. So try to draw that here. So that's n. Then we have a point, arbitrary point, again, in the plane, and that could be the coordinates of that point. We don't know what they are. So it's x, y, z. That's how we call them, and that's the point P. Then we have, I just want you to notice, we have the vector r that goes to, that's a position vector from the origin. And that's the origin, or it's OP. So it's this vector. And we've got vector r naught, and I can probably put it here. That's the position vector for the point P0, or it's the vector OP. So, and again, that's the vector. So now if we do r minus r0, again, that vector minus that vector, we get this vector. So, and this is, the vector is in the plane. And since this is a vector in the plane and n is perpendicular to the plane, so that vector will be perpendicular to n. So perpendicular or orthogonal. So we know that this vector, and we can also call that P0. P is the same thing as R minus R0. They're exactly the same thing. So, and I put it here. R minus R0 is represented by P0P. Now we know these two are perpendicular. Again, watch the dot product. If two vectors are perpendicular to each other, the dot product of two vectors, of these two vectors, are going to be 0. So if I write n dot r minus r naught, you should get 0. Or you can kind of distribute n. So n dot r minus n dot r0 equals to minus n dot r0 is 0. So you can write n dot r equals to n dot r0. So this is the vector equation of the plane. A couple of things I want you to notice before I go to the next page. The components of vector n is ABC. The components of r are x, y, z. And the components of r naught, let me put that here, r naught, use a better color, is x naught, y naught, and z naught. So, and I put the note also, if u is perpendicular to v, u and v are two vectors, then u dot v will be 0. So make sure to remember that. We're going to use this during the entire course. So now if you want to find the scalar equation of the plane, we know that, and I wrote that again. And the component of n is ABC. The component of R is components of R is X, Y, Z, and the components of R0 or R naught is X0, Y0, Z0. We're going to apply that. So which was the vector equation of the plane. So let's write that with the components. So what we can say, or we can just say n dot r minus r0 equals to 0. It's the same thing. So r minus r0, we know we can write x, y, z, the components minus x naught, y naught, z naught. And if you get that, you get this vector. So that vector is x minus x naught, y minus y naught, and z minus z naught. N dot r minus r naught is ABC, the components dot x minus x naught, y minus y naught, and z minus z naught equals to 0. The dot product, please watch that video. When you do the dot product of two vectors, you take the first component of that vector times the first component of the second vector plus the second component of the first vector times the second component of the second vector and times the third vector component of the first vector times the third component of the second vector. So, and you can be, could be in Rn or R2, so it doesn't matter. Here we are in R3, so that's why we get 3 of them. So now I put a note here to find the equation of a plane. So this gives you basically the equation of the plane. Now, what do we need to find the equation of a plane? We need the components of n, the normal vector, and the coordinates of a point in the plane, x0, y0, and z0. So these are the steps. If you want to find the equation of the plane, you need to find out the components of vector n, and you have to have a point in the plane so you can use this equation. So now if you simplify this, then you're going to get ax plus by plus c is equals to d. With an example, it's going to be much easier to see. And if the plane passes through the origin, then d is 0. So remember those. Let's do this example so you see how it works. Find the equation of the plane through the point 2, 4, -1, having the normal vector with components 2, 3, and 4. We know we can write the equation here. So a times x minus x0 plus b times y minus y0 plus c times z minus z0 equals to 0. Substitute. We have the components of n. It's right here. And we have the coordinates of the point, which is here. You just substitute and simplify. I'm sure you can simplify this. And if you do that, you get 2x plus 3y plus 4z equals to 12. So, and you can probably simplify this one. So if you divide everything by, let's say we can, no, we can't actually. You can just leave it like that. Let's take a look at example 2. Find the equation of the plane that passes through the origin and is perpendicular to this vector. When you hear the word perpendicular, a plane is perpendicular to a vector, then you know this can be that vector is parallel to n, or the n can have the same components. So, and I put it here. Number 1, n and v are parallel. So n can be, it's a, b, c, and we can just take that 1, -2, and 5. Coordinates of a point on the plane, so it passes through the origin. So we know it's 0, 0, 0. You can apply the same equation. A times x minus 0 plus b times x y minus y0 and plus c times z minus z0 is 0. So we have everything here. 1, -2, and 5. They come from that that's vector n now, and these are all zeros because passes through the origin. And if you simplify that, you're going to get x minus 2y plus 5 is equals to 0. And you notice this number is 0 because the vector passes through the origin. Next one, find the equation of the plane that passes through this point with coordinates 5, 3, 5 with normal vector of 2i plus j minus k. Here I just put I just changed the notation for you to get familiar, because a vector can be, the components of a vector can be written like that, or just 2i plus 1j minus 1k. So I put n and I just changed the notation, and these are our a, b, c. And again, always you use the same equation: a times x minus x0, b times y minus y0, and c times z minus z0. You just substitute. We have 2, 1, and negative 1, 2, 1, and negative 1. These are the components of n, and we have the coordinates of this point: negative 5, negative 3, and negative 5, because it's minus. And you see, if you simplify this, you get 2x plus y minus z equals to 8. Next example, find the Cartesian equation for the plane containing 3 points, A, B, and C. Now let's see how we can go ahead and solve this problem. So again, we need to find the components of n. So if I have 3 points, this is my A, B, and C. So forget that for a second. That's what we need to find, actually. But what we need, we know that we can find this vector AB. Actually, AB is here, and we can find that vector. And if you cross multiply these two vectors, that's the cross multiplication of two vectors gives another vector that is perpendicular at the same time to the first and second vector. So you can get the components of n if you cross multiply AB and AC. And one more time, watch that recording on cross multiplication. I will do it here for you, but if you watch that video, it's going to be very, very helpful. Now let's find the components of AB and AC. So AB, this vector, again, finding the component is 3 minus 1. The x component, the y component is 1 minus 2. It's right here. And the z component is negative 1, negative 4. So we have the components of vector AB. The components of vector AC is again 6 minus 1. I wrote it here. The y component is negative 3 minus 2, which is here. And the z component is negative 2 minus 4, which is negative 6. Now the cross product of A, B, and AC, the vectors A, B, and AC is going to give you the vector n. The cross product of A, B, and C is a vector orthogonal or perpendicular to A, B, and AC. Now let me tell you how. If you have seen cross product, that's very good. If you haven't seen it, I'll do it for you here. However, watch the my recording on cross product. It's a short recording and shows how to find it. You want to find the cross product. This is just the determinant of this matrix. We are going to do determinants in detail, but then remember, let's just watch and try to learn that right here. So if I want to find the I component of the cross product, I component, so what do you hide the row that contains I and the column that contains I, and you're left with these numbers, and you find the determinant of that 2 by 2 matrix. The determinant of this matrix is that times that, A times D minus, again, that times that, and I wrote it here. So it's negative 5 times negative 6 minus negative 5 times negative 5. So and that's the I component. Then when you go to the second one, the sign changes. For now, to remember this, we are going to learn all this in detail, and I'm sure you have seen this in algebra. Then it's minus the J component of the cross product. You cross the column with J and the row with J. So what you're left with this matrix, and you find the determinant of that matrix. So it's going to be 2 times -6 minus -5 times 5. And I wrote it here, and that's going to give you the J component of the cross product. For K component, again, you can hide the row of K and the column of K. You're left with this matrix. Find the determinant is that times that minus that times that. So, and I wrote it 2 times -5 minus -5, -1 times 5, and that's the K component. If you simplify all this, you're going to get -19I minus 13J and minus 5K. And of course, we can go back to our equation, and we need the coordinates of a point and the components of vector n. This is our n right now. So, and I can put here n equals to. Now you can take any of the 3 points. So you can take point A, point B, or point C, and you're gonna get the same answer. I picked point A here. So you can try it. Well, I try to check that with the second point. But what you can say is -19 x minus 1, because A was the coordinates of A was 1, 2, 4. Minus 13 times y minus 2 minus 5 times z minus 4. Simplify this, you get -19x, -13y, -5 is equals to -65. That means 19x plus 13y plus 5z is 65. You can change all the signs on both sides of the equation. Now there is this definition, another way of finding that. So it says vector equation for plane containing a triangle. So if you have 3 points, so in the plane, again, what you can do is find the components of u and v. So basically here, if we have ABC, u will be the same thing as AB, and v will be the same thing as AC. And I wrote it here. So it's just different notation. Instead of PQR, the problem uses ABC. So then once you find the components, then it says a point X, Y, Z on the plane. This is the notation for the plane. Please learn that. Also containing the triangle PQR if and only if the corresponding vector XYZ satisfies the vector equation that we have here. So, and you can find that vector equation. OP is just the position vector for the first point, plus R times U and B. R and S, these are just constants, and plus R times U plus S times B, and you can write it like that. So again, don't forget we're using components. So you have to subtract the coordinates. Now, what does that mean? We know the span of, if you watch the video on the span of 2 vectors that are not collinear or coplanar, 2 vectors, the span of those 2 vectors is an equation of the plane through the origin. But what happens, they can just take the span of UV. However, it's the translate, kind of you add that constant vector. So that's why we have that. To find the span of UV, you don't need this, which is going to be a plane through the origin. You kind of think the plane starts from that point. So that's what it is. Now let's see how we can use this to find the same example to find it. Find a Cartesian equation for the plane containing, this is the same problem I want to solve it. the way the way that the definition says. So you have to find AB and AC. That's, I'm sure you know how to find that. In the definition, this is same as PQ or U, and that's same as PR or V. Then you write the vector equation right here. So OP, the coordinates of the components of OA, we know it's going to be 1, 2, 4, and we have the components of U and V. So we found them here. You just substitute. Here you're going to get three equations. Number one, x equals to 1 plus 2r plus 5s. Y equals to 2 minus 2r minus 5s, and I have it here. And z is 4 minus 5r minus 6x, which is right here. You want to have an equation with x and y only. So to solve that, again, you can add 1 and 2. If I do that, 1 plus 1, you can write, well, the left side, first of all, is going to be x plus y. The right side, 1 plus 2 is 3. 2r minus r is r. And the reason why we did that, we want to cancel s's because 5s minus 5s is 0. So you're left with that. Now, if we go to 2 and 3 or 1 and 3 and you cancel s again, then you can eliminate s and r. Let's see what I did. I multiplied -6 times the second equation plus 5 times the third equation, and I wrote them here. Now if you do -6 times the second equation plus 5 times the third equation, you get -6y plus 5z, so that's -6y plus 5z on the left side. -12 plus 20 is 8. 6r minus 25r is -19r, and I, of course, the s's, and these are not z's, these are s's. Let me fix those for you. They cancel, and that's what you're left with. And guess what? We know what r is. R is x plus y minus 3. So if you substitute r by x plus y minus 3, so and you simplify, you get distribute the 19, get -19x, -19y plus 57, and take x, y, and z's on one side. So that's what I did here. Simplify again, you get 19x plus 13y, and the constants are 8 and 57, which is 65. And you get that answer. And guess what? This was the same problem, and we solved it two ways, and we got the same answer. If you watch those videos on dot product and cross product, again, make sure to know how to solve it both ways. I think it's yeah, doesn't make any difference, but then these are short videos. Watch them so you can understand that way also. And I think that's good enough for the planes, the equation of the planes. Please watch this 2, 3, 4 times, and dot product and the cross product videos also. Thank you for watching. Have a great one, and I will see you soon. Bye-bye.